Section 7.1, the basics of solving quadratic equations. To begin, we have solved quadratics, and when we solve them, we use factoring. Now we will see the whole picture of what quadratics are, meaning we will learn how to graph them and what solving a quadratic represents. So for an example, a review example, recall how to solve a quadratic. So we're being asked to solve a quadratic using the principle of zero products. So the principle of zero products says if I have two things being multiplied and they equal zero, that means one or both of them is zero. All right, and the way we can use the zero product property in quadratics, we have learned how to factor. So if we can factor it, so I have a factor times a factor equals zero, then I can solve using the zero product property. All right, so let's factor this first one. What numbers multiply give us negative 16, but add to give us 6? So 8 and 2 work, right? And we need a positive 6 and the multiples to multiply give us a negative. So that works. And so this factors because I have just an x. This factors to be x plus 8 and x minus 2. And then I can set each one equal to 0. And we get that x equals negative 8 and x equals 2. And we can factor the next one. Now, because leading coefficient is not a 1, I have to proceed differently. So I multiply my first and my last. So 6 times negative 5 is negative 30. And we do that same idea. We want to think of factors that multiply to give us our a times our c, but add to give us our b. So numbers that work for this case are 3 and 10. We need, oh no, 3 and 10 doesn't work because we need to make one of them negative. How about 15 and 2? And we can make 15 negative. So 15 times positive 2 is negative 30, but negative 15 plus 2 is negative 13. So we replace our middle term with our two new terms. So we have 6x squared minus 15x plus 2x minus 5 equals 0. We can factor our first two and our last two. So for our first two, you can factor out a 3x, so I'm left with 2x minus 5. And then you want to get the same thing in the parentheses. We're already there, so let's just use a placeholder of 1. So this factors to be 3x plus 1 and 2x minus 5 is equal to 0. We set each one equal to 0, and then we solve. So we get x is equal, we subtract 1, we get negative 1 over 3. X is equal to, we add 5, so it's positive, 5 pi over 2. 5 over 2, no pi. Next, definition of the quadratic equation. An equation of the type ax squared plus bx plus c equals 0, where a, b, and c are real number constants and a has to be greater than 0, is called the standard form of a quadratic equation. So these numbers a, b, and c are numbers. Our variables are the x and the x squared. Now a quick note. The U-shaped figure that quadratic equation creates when it's graphed is called a parabola. We will talk more about this in section 7.4 when we go over about how to go about graphing a parabola. For example, if we graph the equation x squared plus 6x plus 8, we get this parabola, and what we're working for is to get these points that cross our x-axis, their x-intercepts. That's what we get when we solve a quadratic. So when we're solving, I just want you to be aware of what we're doing. When we're solving a quadratic, we want to see where they cross the x-axis. Now you can get a whole number, a fraction, you can get an irreducible radical, which is irrational, which is a never-ending decimal, but you can also get results with an I. If you get a result with an imaginary number, then it means it just never crosses our x-axis, meaning we have a graph that never touches your x-axis. Therefore, there are no x-intercepts. So that's what's going on when you get imaginaries. Also, if the equation begins with a negative, it opens down. If it starts with a positive, it opens up. So meaning, like here, we see that we start with a positive x squared. That's why it opens up. That's how it translates into the graph. If I were to start with a negative x squared, then it would open down and make a U-shaped figure. So parabolas can open up and open down. Let's do an example. Solve x squared equals 25. All right, so we have, well, actually, the only method we have under our belt is factoring. We're going to learn two new methods in this section. So to solve, we need to set it equal to 0. So let's go ahead and subtract 25 to both sides. So we're left with x squared minus 25. All right, we can factor using differences of squares to be x plus 5, x minus 5. And so now I have x plus 5 is equal to 0. X minus 5 is equal to 0. We subtract 5, we get x is equal to negative 5. Plus 5, x is equal to positive 5. So we have solved, and these are x-intercepts. If we want to, you can write them as a point. So negative 5, comma 0, and 5, comma 0, because they're actually points in your graph. Next problem. We're asked to solve, and so far all we know is how to factor. So we can proceed by factoring. We can factor out a greatest common factor of x. We can actually factor out a 3x, right? So that we have 2x minus 5, and we can set each factor equal to 0. 3x equals 0, 2 minus 5 is equal to 0, divide by 3, x is equal to 0. And x is equal to 5 over 2. So we have solved. I'll let you finish the next one. When you are working to factor, you need to make sure it's set equal to 0. So we need to move these two numbers over. 3x squared is equal to 2 minus x. So minus 2 plus x minus 2 plus x. We have 3x squared. And remember to write it in standard form. Plus x minus 2 is equal to 0. Now you can proceed to factor. And I'll let you finish that one. Solving equations of the type x squared equals d. And we saw one like this already. We had x squared equals 25. So let's learn a different method to solve for such equation. The definition is called the square root principle. The principle of square roots. The solution of the equation x squared equals d and square root of d and negative square root of d. When d is greater than 0, solutions are two real numbers. When d is equal to 0, the only solution is 0. If d is negative, meaning less than 0, there are two imaginary numbers. So what we're saying is we can apply the square root to both sides. So take a look at the example we just did. The first example, x squared equals 25. Well, this says that what this method is also called is a square root property. So we can undo the square by taking the square root of both sides. So we can go ahead and take the square root of both sides, thus undoing this square and this square. And we're left with x is equal to, when we do this, we need to write plus or minus the square root of 25. And you can punch that into a calculator, but actually this one's a perfect square, so you might catch that it's just 5. So our answer is two answers, positive 5 and negative 5. So here's an example of the square root property. Now here's a note. We often use notation plus or minus to represent the positive and the minus. Consider x squared equals 25. What can x be? We see that both negative 5 and 5 could work. So we need to consider both a negative and positive option. Let's do an example. Let's solve 3x squared equals 6. Give the exact solution, approximate solution to 3 decimal places. All right, so 3x squared equals 6. We first need to get that quantity squared by itself. We can do that by dividing the 3 out, so that we're left with x squared is equal to 6 divided by 3 is 2. Okay, now I can undo that square by taking the square root on both sides, but when I do that, I have to consider the positive and the negative, so I need to write it plus or minus. All right, we see that the square root and the square undo each other, so we're left with x is equal to plus or minus 2. So my answer is x is equal to negative square root of 2 and positive square root of 2. This is called our exact solution. Now we can also punch into our calculator to get an approximate solution. I'll let you go ahead and do that one. Example 5. Solve negative 5x squared plus 2 equals 0. Give an exact solution and approximate the solution to 3 decimal places. All right, let's go ahead and do that one. So our goal here, well, our first goal is to get that x squared by itself. So let's go ahead and subtract 2, subtract 2. You get negative 5x squared is equal to negative 2. Let's go ahead and divide a negative 5. And we get x squared is equal to 2 divided by 5. Now I can go ahead and take the square root. Don't forget to write plus or minus. And we're left with x is equal to plus or minus the square root of 2 divided by 5. So our answer is x is equal to 2 over 5 square root and negative 2 over 5 square root. You can punch this into a calculator to get an approximation. All right, next one. Let's subtract the 9 to get the 4x by itself. So we get 4x squared is equal to negative 9. Let's divide by 4. Divide by 4. You get x squared is equal to negative 9 over 4. You can take your square root. Don't forget plus or minus. So that we're left with x is equal to plus or minus the square root of negative 9 over 4. Now what happens when I have a negative? Remember, we just write an I because we have an imaginary number. So we write this as x is equal to plus or minus I square root of 9 over 4. So you can write x is equal to plus or positive I square root of 9 over square root of 4 and negative I square root of 9 over 4. Solving functions of the type x plus c squared equals d. Equations like x minus 2 quantity squared equals 7 can be solved using principle of square roots, just like we've done before. So let's go ahead and do so. So let's go ahead and do A. Solve x plus 2 squared equals 7. All right, we can go ahead and take the square root. Don't forget the plus or minus. And we're left with x minus 2 is equal to plus or minus square root of 7. And we can just continue. We need to get x by itself, so let's add 2 to both sides. We get x is equal to plus or minus square root of 7. And that is our answer. We can find out what the square root of 7 is using a calculator, and then add 2, and then subtract 2. Next example. Now, we can also try to do that if we notice that one side of our equation is a perfect square trinomial. And here we see that the only way to get multiply get 6 and add to get 9 is using 3 and 3. So this is actually 3x plus 3 squared equals 2. So I can proceed doing it the same way as above. I'll let you finish that one. Completing the square. This is a super important piece of knowledge that you'll need throughout your math career. So make sure we understand it and we ask questions and we practice it. This new process of completing the square can be used to solve any type of equation, even those that cannot be factored. To do so, we force a perfect square trinomial. We will force the equation to look like x plus c squared. Definition of completing the square. When solving the equation to complete the square of an expression like x squared plus bx, we take half of the x coefficient. In this case, it's b over 2 and squared, and we add the number. So we're going to go ahead and use this definition of b over 2 squared on both sides of the equation. Now, if you happen to have a fraction, you can also treat it as b times 1/2 quantity squared. You can also write it that way in case you're working with a fraction. Okay, now here are your steps to work with completing the square. To solve an equation ax squared plus bx plus c equals 0 by completing the square, 1. If a is not equal to 1, multiply by 1 over a so that the x squared coefficient is 1, meaning divide everything by a. Once x squared is 1, add or subtract to the equation in the form x squared plus bx equals negative c, or x squared plus b over ax equals negative a over c. Take half of the x coefficient and square it, and add the result to both sides. Express the side with the variables as a square of a binomial, and use the principle of square roots to complete the solution. All right, let's go ahead and start with this problem. All right, so our first step is if a is not 1, divide by a. So here we see our a is 1. You see x squared? We don't have like a number in front of the x squared, so it's 1. All right, now let's go ahead and move your constant to the other side. So we have a, b, c. Move your c to the other side so that we have minus 8 minus 8. We have x squared minus 6x equals negative 8. Now we're going to use this formula that we were given, b over 2 squared. So our b is negative 6. We're going to use b divided by 2, and we're going to square it. Once we get that number, we're going to add it to both sides of our equal sign. All right, so our b in this case is negative 6. Let's take negative 6 divided by 2 and square it. Negative 6 divided by 2 is negative 3 squared. Negative 3 squared is 9. So we're going to go ahead and add 9 to both sides. Now we're going to factor. The whole goal was to create here a factorable perfect square trinomial. So if we try to factor, so what numbers multiply give us 9 that to give us negative 6? It's negative 3 and negative 3. Notice it's the same number before you square it. So you don't even have to do much thought effort. It's always a number before you square it. So that we get x minus 3 squared is equal to negative 8 plus 9. We get positive 1. All right, now let's go ahead and continue using our square root property. Let's go ahead and take the square root of both sides, plus or minus. So we're left with x minus 3 is equal to plus or minus the square root of 1. And we can go ahead and add 3 to both sides to make it go away. And we're left with x is equal to 3 plus or minus the square root of 1. So I get x is equal to 3 plus square root of 1 and 3 minus square root of 1. Alright, well the square root of 1 is just 1. So 3 plus 1 is 4, 3 minus 1 is 2. So these are our answers. Let's do one more. Let's see the next example. I'll leave you to try the one above. Alright, so what's different about this one is that my a is not 1. So I have to divide out my a. Alright, so you have an equal sign. You can just divide everything by 3 or just your numbers that you're working with. If you divide everything by 3, if you divide it out, then it's gone. But it might not be ideal because you're going to be forced to work with fractions. It's your call. But let's just write the division. So we have 3 divided by x squared plus 7 over 3x. So you see, I didn't divide it out. It's not gone. I'm just showing the division. All right, now we're going to use that formula, b over 2 squared. Now here, my b isn't so pretty to work with because it's a fraction. So let's go ahead and rewrite it so that I have b times 1/2 squared, because it's the same exact idea as dividing by 2. All right, so if I do that, I have my b is 7 over 3 times 1/2. You get 7 over 6. So I have 7 over 6 squared, and so that gives me 7 times 7 is, well, let me write it this way. 7 squared over 6 squared, so it gives me 49 over 36. So I'm going to write right here 49 over 36. But to write it on the other side as well, I have to multiply it to the one in front. I always say think of it as asking permission to go out with your friends. So we need to multiply it by 3. So let's do some work. 49 over 36 times 3. While here it goes into it twice, 12. So we're left with 49 over 12. Alrighty. Now, remember when we're trying to factor, it's a fraction now. Factoring isn't so pretty. And remember, it's always a number before you square. So you have x times, you have a positive, so plus 7 over 6 squared is equal to 9 plus 49 over 12 plus 2. Let's do that work. So that we get 2 over 1 plus 49 over 12. We get 24 over 12. I multiply by 12 over 12. Plus 49 over 12. We get 373 over 12. All right. And now you can proceed using the square root principle. All right, I'll let you try the next one. So completing the square is kind of different, but with practice, it's not so bad. This is section 7.1, the basics of quadratic equations. Thank you.